Welcome back to my channel. Today we will continue discuss on subtopic 1.3 electric potential. Example 7. A 2-point charge here we have Q1 positive 0.3 coulomb, Q2 is negative 0.4 coulomb are separated by the distance of 6 meters. So here we have a positive and also negative point charge. Calculate the electric potential at point A where it's 3 meters from the charge Q1. Okay, so since the total distance between Q1 and Q2 is 6 meters, therefore Q1 and QA is here mentioned 3. So here is 3 meters. Of course, A to Q2 also is 3 meters. Okay, so we want to find the total electric potential at point A. Okay, so at point A, our electric potential is influenced by a point charge from Q1. Okay, so for Q1, the point charge for Q1, it will give influence on point A. For Q2 is a negative charge. Similar, Q2 also will give influence on point A. Okay, so point A actually experience 2 electric potential. Okay, so we can write as V at point A is actually influenced by V1 plus V2. Okay, meaning that there is 2 point charge that give influence on that point. So V1 is equal to KQ1 over R. R is 3 meter plus KQ2 over 3 meter as well. So we substitute into the equations where we can factorize out. K is 9 exponent 9. 3 meter we can factorize out. Okay, Q1 is positive 0.3 coulomb. Okay, plus Q2 is negative 0.4 coulomb. Okay, so remember, negative charge here we must substitute, or negative positive here we must substitute, we must consider, because this is indicate the value of the electric potential. Okay, so after pressing the calculator, we notice that VA at the electric potential at point A is equal to negative 3 exponent 8 volt. Okay, so this is question 7. Okay, next we go to example 8. Here we have a 2-point charge, 12 nanocoulomb and negative 12 nanocoulomb are separated by the distance of 8 cm. Okay, so here we have a 2-point charge, positive 12 nanocoulomb and negative. Okay, determine the electric potential at point P, where point P is 6 cm from the charge Q2. So this is the point that we want to find. Okay, similar, at this point, it actually influenced by Q2. Okay, let's say this is the Q2. Okay, so Q2 here, it gives influence on point P. So I label as VP. V. So I label as V2. Okay, similar for Q1. Q1 also will give influence on point P. Okay, where the distance here is, we can find it because this is 6, this is 8, of course this one will be 10 cm, so this distance is 10 cm. Okay, so when you reach point P, okay, it will also give influence on point P, so I label it as V1. Okay, so meaning that at point P is actually experience 2 electric potential. One is from point charge Q1, another from Q2. Okay, so you substitute into the equations where K is 9 exponent 9. Q1 is positive 12 nano, and the distance is 10 cm, so it's 0.1 plus V2. Okay, V2 here we substitute 9 exponent 9. And the charge is negative 12, so it's negative exponent negative 9 over distance is 0.06. Okay, so after pressing the calculator, we found that the electric potential acting on point P is negative 720 volt. Example 9 is the question related to the potential difference. So here we have Q1, 2 nanocoulomb, Q2 is negative 6.5 nanocoulomb, are separated by 0.1 meter apart. Point A is a midway between them. Point B is 0.08 from Q1 and 0.06 from Q2. Okay, so A, find the electric potential at point A. So at point A is actually influenced by 2-point charge. One is from Q1, another one is from Q2. So our VA is influenced by 2-point charge. Okay, so we substitute 9 exponent 9. Q1 is positive 2.4 nano. And then the distance is 0.05 plus V2 is 9 exponent 9. And the point charge for Q2 is negative. Remember, you must substitute positive, negative, the sign of the charge into the equations for V. Okay, so it's negative 6.5 exponent negative 9, and the distance also 0.05 meter. Okay, so our electric potential at point A, or VA, is equal to negative 738 volt. Okay, so this is at point A. Okay, next B, we want to find the electric potential at point B. Okay, now at point B, so similar at point B, you will also experience the electric potential from Q1 and also Q2. Okay, so I will write VB is equal to V1 plus V2 because here we have 2-point charge. So it's equal to 9 exponent 9, and the charge is positive 2.4 exponent negative 9. Okay, and the distance between point B and also Q1 is 0.8. Okay, so I will write 0.08 plus 9 exponent 9, and then Q2 is negative 6.5 exponent negative 9, and the distance between charge Q2 and B is 0.06. So I substitute here 0.06. Therefore, the electric potential at point B, we will get negative 705 volt. Okay, so this is the electric potential at point A and point B. Okay, see, we want to find work done by the electric field on the test charge is 2.5 nanocoulomb that travel from B to point A. Okay, so our work done equation is from B to point A. Okay, so the equation is Q times change of the electric potential. Okay, Q is the test charge, where test charge is 2.5 nano, and V, we must take V final minus V initial. Okay, so here our V final, because it's from B to A, so our V final is VA. Okay, where VA just now is negative 738, okay, minus negative 705, so this is VB. So the work done by electric field on the test charge, we will get negative 8.25 exponent negative 8 joule. Okay, so this is the work done to move the test charge from B to point A. Okay, next we will go to example 10. Okay, a test charge of a positive 2.3 exponent negative 4 coulomb is 5 cm from the point of charge Q. A work done of positive 4 joule is required to overcome the electrostatic force to bring the test charge Q to the distance of 8 cm from the charge Q. Okay, so calculate the potential difference. We want to find the potential difference delta V between 8 cm and 5 cm from the point charge. Okay, so meaning that here we have a point charge Q, where here we have 5 cm and also 8 cm. Okay, so the test charge of 2.3 exponent 4 is 5 cm from the point Q. So we need to do a work of positive 4 joule to overcome the electrostatic force to bring the test charge to the distance of 8 cm. So initially the test charge is at 5 cm. After that, it will bring it to 8 cm. Okay, so this is the work done. So we need to calculate, okay, the potential difference between the 8 cm and 5 cm from the point charge. Okay, so we know that work done, okay, is from, let's say I label it as this one is A, this is point B. Is bringing the test charge from point A to point B. Is equal to test charge times change of the potential difference. Okay, so our work done is positive 4, and the test charge is positive 2.3 exponent negative 4, okay, times the delta V. And delta V is the potential difference that we want to find. Okay, therefore our delta V is equal to 1.74 exponent positive 4 volt. Okay, so actually this delta V here is V final minus V initial. Okay, where we bring A to B, meaning that it's actually VB minus VA. This is the value where VB minus VA is equal to 1.74 exponent 4 volt. Okay, so this is actually VB minus VA because we must take final minus initial. Okay, next, find the value of the point charge. So this is the point charge that we want to find. Okay, just now this is the test charge. So now we want to find point charge. What is the value of the point charge? Okay, so what should we do is we must find out first. Okay, just now what we get is the delta V, the potential difference, where we know the potential difference is VB minus VA. Or we can write as KQ over R. Okay, KQ over R minus KQ over, okay, let's say this is RB, this is RA. Okay, and the value is 1.74 exponent 4. K is the constant value, 9 exponent 9. Okay, Q is the point charge that give influence on A and also give influence on B. Okay, so we factorize out. And then 1 over RB is 8 cm, 0.08 minus 1 over 0.05. Okay, so if you press calculator, we will find that the point charge, the value for point charge is equal to negative 2.58 exponent negative 7 coulomb. Okay, so this is the answer for the point charge. Okay, next, find the magnitude of the electric field strength for the charge of Q at the point of 5 cm from the charge Q. So this is the point charge. So we want to find the electric potential. Okay, electric potential, where from here, this is the point charge Q. We want to find at 5 cm, meaning at point A here, what is the value for electric field strength. Okay, so electric field strength E is equal to KQ. Q is the point charge over R. Okay, R square. So we substitute K is 9 exponent 9. Q is the point charge, where point charge we get is a negative 2.58 exponent negative 7. So usually we will just ignore the negative because this is a vector quantity, so you don't need to substitute negative. And the distance is 0.05. And remember to square it up. So the electric field strength, the value that we will get is 9.29 times exponent 5 Newton per coulomb. Okay, and just now our Q here actually is not positive because here we already mentioned is the negative. Here is negative, so this one also negative. Okay, so this is the answer. Because the question only mentioned magnitude without direction, so we just give the magnitude 9.29 exponent 5 Newton per coulomb. Okay, so that's all for this video. Thank you. See you on next video. We will continue discuss on the potential energy. Okay, see you. Bye.